So I thought it would be a good idea to buy uranyl nitrate and thorium nitrate from the internet, and since we have the necessary equipment to check what's inside, I should do that. Alright, both of them are radioactive, but the thorium nitrate normally is not 4 times as active as the uranyl nitrate. What does the Geli detector say about that? And here's where the fun begins. Take a look. This is the spectrum of uranyl nitrate. Don't worry, at first glance I couldn't make much of it either. But here is the gamma spectrum of the thorium nitrate. Do you notice anything? I will overlay them. This is not a trick of my part. They are the exact same spectrum. And I compare that with uranyl nitrate that we normally use in the laboratory, and it's not supposed to look like that. But what do we have here? We can see radium-224 and lead-212, as well as thallium-208 and bismuth-212. As a final clue, we have some actinium-228 lines. These only appear in one decay chain, the thorium chain. So both of them definitely contain thorium. Good for the thorium nitrate, but not so good for the uranyl nitrate. And yes, I've checked, there's not a single line indicating the presence of uranium-238 and uranium-235. So there's no trace of uranium in the uranyl nitrate. Now I have a mission. What is this supposed to be? Uranyl nitrate? And with the thorium nitrate, I only now know that they're thorium. Chemical test will prove in what form the thorium is contained. Let's first test the water solubility. Thorium nitrate dissolves as expected, but the uranyl nitrate is a bit strange. There shouldn't be white chunks at the bottom, and why is it so yellow? Real uranyl nitrate in solution looks like this. And to be absolutely sure that the thorium nitrate really is thorium nitrate, I have to perform a nitrate test. I do that by boiling it in concentrated hydrochloric acid, and the formation of brown nitrogen dioxide gases proves that there is really indeed thorium ions and nitrate ions in the substance. Okay, let's bring out the next big piece of equipment. The X-ray powder diffractometer. The finely ground substances are now pressed into the wells of the sample holder and inserted into the diffractometer. Using X-rays, the device can determine the structure of the crystalline solid and deduce the composition of the substances from the data. What we get is a diffractogram where the reflection intensity is plotted against the angle between the radiation source, sample and detector, denoted as 2 theta angle. In this case, copper K alpha rays are used for analysis. Explaining how and why X-ray diffraction works would exceed the scope of this video. Nevertheless, we are presented with a bunch of reflection, and with the information of the previous chemical tests, we know that there's thorium, nitrogen, oxygen and hydrogen present. So the entry of the thorium nitrate pentahydrate from the database accounts for a large portion of the reflection. Most of the missing ones are explained by a basic thorium nitrate salt with this formula. As for the supposed uranyl nitrate, we didn't know anything from the previous tests. Accordingly, we just let the database do its thing, and it's potassium chromate. What the fuck? The white crumbs when dissolving must have been some insoluble thorium compounds, but it's definitely not thorium dioxide that would have been visible in the XRD. So if this is really potassium chromate, then we have one another chemical test. Chromate ions form dichromate ions when placed in acidic solution. The color should turn orange. Let's take a look.
Ja, geil.
Well, that was our reaction to the final test, which confirms all the results once again. This stuff is not uranyl nitrate. It neither contains the uranyl ion nor the nitrate ion. Even if it were, the displayed formula would have been wrong. And this stuff is thorium nitrate, but the Cas number is wrong. That's from manganese 2 chloride. Of course, I told the seller all of my findings and I got my money back for the uranyl nitrate, and I can still use the thorium nitrate for future videos on the chemistry of thorium. The seller had no idea about these chemical data, he was just a simple reseller. But it should be really embarrassing if you write really long texts about these magical substances and what wonderful application it has, and it's simply not the substance that you claim. So what do we learn from this? Do not buy uranium and thorium compounds online from dubious sellers. Or, a bit more generally speaking, do not buy radioactive stuff if you don't have the right equipment to handle it. I have the privilege to test such things at the university, and a big thank you goes out to Nico and Thomas, without whom I could never have done the X-ray powder diffractometry. With that being said, goodbye!